Hello, good morning children. How are you all? Hope all of you have gone through the video which was of the chapter structure of the atom and understood the concept of structure of atom very well. Now let's continue with the chapter. Before continuing with the chapter, let's recall what we have learned in the last two classes. We have what we have discussed about the structure of atom, and as you know that earlier it was considered atom is indivisible, but later with the discovery of subatomic particles like electrons, protons, neutrons, atomic nucleus, it was known that atom is divisible into subatomic particles. And later we have already discussed that in 1900 how the J.J. Thomson's model of an atom, according to him, he gave the model of an atom like a plum pudding model where the protons were the positively charged sphere and in that the negatively charged electrons were found to be embedded. That was the plum pudding model which was given by J.J. Thomson. Earlier before that, scientist Goldstein, he had also proposed that through his gas discharge tube, he had come to the discovery of canal rays which were positively charged, and then later these canal rays were named as protons, okay, having the magnitude of 1 unit and the mass is almost 2000 times more than that of electrons which are negatively charged, and the mass of the electrons were found to be very negligible or very small. Later, that is after the discovery the structure of atom given by J.J. Thomson, there was a great discovery in the field of structure of atom by Rutherford, which we had discussed in our last class. That is by alpha particle scattering experiment of Rutherford by using a gold foil, which led to the discovery of atomic nucleus. And according to him, it was said that the atomic nucleus is positively charged and it occupied very small space in the center of an atom, and electrons were found to be revolving around the nucleus. But the major drawback of Rutherford's model of an atom was that it was said that when electrons revolve around the nucleus, it tend to lose energy and tend to fall, and due to the centrifugal force, it may lose energy and finally it will fall onto the nucleus, making the nucleus highly unstable. But we all know that nucleus is stable. So this model, that is the drawback of Rutherford's structure of an atom, was rectified by another great scientist named Niels Bohr, where he said that yes, there is a center of an atom called the nucleus, and electrons revolve around the nucleus in certain fixed orbits, and the fixed orbits were given it was denoted by the letters like capital K, L, M, N, O, like that, or that is energy level N, that is energy level 1, 2, 3, 4, starting from the innermost to outermost. So the energy level which was very close to the nucleus is said to be having the minimum energy, and as you move away from the center of the nucleus, center of the atom, the energy level will try to increase. So that was the model given by Niels Bohr. So today let's study about how these electrons are distributed in various energy shells and what are the rules to be followed when we write the distribution of electrons of an atom, of an element. Now, the distribution of electrons in an atom of an element, it's known as electronic configuration, and the knowledge of electronic configuration is very important because it will allow you to find out whether an element with the electronic configuration, whether it is a metal or a non-metal, and also you will be able to find out the valency of an element, that is the combining capacity of an element, how the element is going to combine with the atom of another element, what kind of bonding, chemical bonding it is going to form, and also what kind of chemical reaction that particular element will tend to undergo. So this is very important concept, so let's concentrate on that. So the electronic configuration, the rules for that, how the electrons occupy in the various shells around the nucleus, was given by two scientists, that is Bohr and Bury. So according to Bohr and Bury's rules, we'll discuss how the electrons are occupied in various shells. This is the structure of an atom which we had studied in our previous class. This is the center of the atom. It is known as nucleus. The nucleus consists of nucleons, that is protons which are positively charged, and neutrons which are neutral, and both are having the mass of 1 unit or 1 atomic mass unit, and the electrons are found to be revolving around the nucleus in certain fixed orbit. And the fixed orbit I have shown here through 3 orbits. So the first one is K shell with a lower energy which has minimum energy. Then the next level is L shell, M, N, O, P, like that. Now when the electrons are found in the various energy level, so what is the rule? So the first rule is the number of electrons which are present in a number of present in a particular shell is given by the formula 2n square, where n is the number of the shell, that is the first shell or the second shell or the third shell. So for example, the first shell is K shell. How many electrons can be accommodated in the first shell? We can find out by using this formula. So the formula is 2n square. So 2 into n means the number of shell. K is the first shell. So 1 square. So that means 2 into 1 square is how much? 1. So the number of electrons which can be occupied in the first shell is 2. Next one, the second shell is over here, that is L shell. L shell is the second shell. So substitute the values. So 2 into 2 square. That means 2 square is how much? 4. So 4 into, that is you can multiply 2 into 4, that is 8. So maximum number of electrons which can be occupied in the second shell, that is L, is 8. Okay. And the third shell is M. So 2 into 3 square. 3 square means third shell. So 3 square is how much? 3 into 3, 9. So 2 into 9, that means 18. That means maximum number of electrons which can be occupied in the third shell is 18. So first shell is 2, then 8, 18. Let's see how many electrons can be occupied in the fourth shell. So that is equal to 2 into N shell is 4. So 2 into 4 square. What is 4 square equal to 4 into 4? 16. So it will be 2 into 16, that is 32. And like that you can go on calculating the number of shells. The maximum number of shells, like in the periodic table I told you, the elements are arranged in the modern periodic table according to increasing order of atomic number. That will be the next topic which we are going to discuss. And in that, when it is in the increasing order of atomic number, in the periodic table elements are distributed, that is you can very easily find out, that is in the horizontal rows which are known as period, and the vertical columns are called groups. So the number of periods in the modern periodic table is 7. So 7 shells you can find out. So as the new, that is according to the increasing order of the atomic number, as the electrons are going on or occupying in certain orbit, the number of shells also will be going on adding, as in that is as we go from period 1 to period 3, period 4, period 5, like that. Okay, so there is a very nice correlation between the atomic number and number of periods you can find out in a particular element. Now the second rule is nothing but the maximum number of electrons in a particular shell is equal to 8. Okay, that is in the outermost shell. The number of electrons in the outermost shell should be 8. But in hydrogen and helium, these two elements belong to period number 1. They have only one shell, that is K shell. So by the time hydrogen has atomic number 1, it has 1 electron. So 1 electron occupies in the K shell. Helium has 2 electrons, so the 2 electrons occupy the K shell. But we know that the maximum number of electrons which occupy in the K shell is 2. So hydrogen and helium in the periodic table has only one shell, that is K, and K shell can occupy 2 electrons only. Other than that, in L, M and all, when you are saying, if the element has the more than one shell, that is outermost shell, then maximum number of electrons should be only 8. That is an important rule. What is rule number 3? Rule number 3 is nothing but, that is electrons occupy the various shells in a step manner. That is, only if the electrons are fully occupied the inner shell, the next shell will get filled up. So if in the K shell, if the 2 electrons are filled, the next electron will go and fill in the K shell, L shell. And if in the L shell the 8 electrons are fully filled, then only the other electron will be occupying the third shell. So that is the rule number 3. Electrons occupy the shell in a step by step manner. Then only when the innermost orbits are completely filled, the outermost, the next electron will be occupying the next orbit. That is rule number 3. So these all are very important and very easy to learn. Now let's study another important concept, how to find out how many electrons are present in a particular atom, or how many protons are there, how many neutrons are there. And it all depends on two important concepts, that is every element has an atomic number and mass number. So using this we can easily calculate the number of electrons, number of protons and number of neutrons present in an atom of an element. So let's focus on the next topic, that is atomic number and mass number, and also how to calculate the number of protons and neutrons and electrons present in an atom of an element. So children, now let's concentrate on the next concept, that is atomic number and mass number. So atomic number is nothing but it is equal to the number of protons present in the nucleus of an element or of an atom. So that is what known as atomic number. So how many protons, how many positively charged subatomic particles are present in the nucleus of an atom is equal to the atomic number. So it is equal to, atomic number is equal to number of protons present in the nucleus of an atom is known as atomic number, and it is denoted by the letter, that is Z, capital Z, atomic number. So Z is equal to number of protons. Number of protons, it is given by the small letter P. Now you know that in an atom it is neutral, because number of positive charge should be always equal to number of negatively charged. So what are the negatively charged subatomic particles? They are electrons. Protons are positively charged. So what happened? In an atom, the number of positive charge, that is protons, will be equal to number of electrons. So atomic number is also equal to number of protons, which is equal to atomic number, which is also equal to number of electrons. Therefore, you can tell number of protons in the nucleus of an atom is always equal to the number of electrons which are present in the orbit in an atom of an element. This is equal to, so number of protons is always equal to number of electrons, and which together is known as atomic number. So atomic number you can easily calculate when the atomic number is given to you. So you can easily find out from the atomic number, that is what is the number of protons present in an atom of an element and what are the number of electrons present in an atom of element, because always a positively charged protons, the number of protons are equal to number of electrons. So number of protons is equal to number of electrons, which is known as atomic number. Now the next topic is nothing but mass number. Now mass number is what I told you, the entire mass of an atom, that is Rutherford's alpha particle scattering experiment. According to him, what he said, that is mass of an atom of element is located at the center, that is in the nucleus. And what are they called? Nucleons. Collectively, the total number of protons and the total number of neutrons, they are known as nucleons. So that occupies the mass, that is known as a mass number. So mass number is denoted by the letter A, capital A, that is mass number. So mass number A is equal to number of protons plus number. So we are adding it, number of protons plus number of electrons, neutrons, which are present in the nucleus of an atom. So number of protons and number of neutrons, when you add it, you will get the mass number. And collectively number of neutrons and number of protons and neutrons, they are known as nucleons. So since the mass of electron is very, very small or negligible, that is not calculated. That is known as the atomic number. That is mass number, which is represented by the letter capital A. Now from this we can easily find out, if the mass number is given, we can easily find out how many protons are present in the nucleus of an atom, as well as we can easily find out how many neutrons are present in the nucleus of an atom. So from this equation we can find out, suppose if you want to find out how many neutrons are there if the mass number is given. So you can find out the number of neutrons. Number of neutrons is equal to number, that is A, that is a mass number minus number of protons. You can easily calculate how many neutrons are present in the nucleus of an atom. Or if you want to find out how many protons are there, you can just take the mass number and subtract number of neutrons from it. You can find out the number of protons in the nucleus of an atom. So this is very important. So atomic number is nothing but number of protons, which is atomic number, which is represented by the letter capital Z, and this Z is equal to number of protons which are positively charged. But since an atom is neutral, that is, the total number of protons are always equal to total number of electrons. Protons are present in the nucleus of an atom. Electrons are distributed in the various shell. So when all the total number of electrons are taken, that number of electrons will be always equal to the number of protons which are present in the nucleus of an atom. And mass number is nothing but total number of protons and neutrons which are present in the nucleus of an atom. This is how you can calculate it. Now, using this, we will write the electronic configuration of the first 18 elements in the periodic table. Hope all of you have learned that I told you to learn the elements, the symbol of first 18 elements present in the modern periodic table. So let's write the electronic configuration, and from that we are that is using the atomic number, and then we can easily find out how the electrons are distributed, and then later we will be drawing the atomic orbital diagram of the first 18 elements. Now children, let's see how the electronic configuration and how to calculate the number of protons, neutrons and electrons present in an atom of electron element can be done by using this table. Now, as I told you, an atom of an element, suppose this is an element X, the number which is written over here is A, and here the letter is written as Z. So A is nothing but mass number and Z is the atomic number. Now, if this is given to you, how to calculate the number of protons, neutrons and electrons in the atom of an element? So, for example, the first element in the periodic table is hydrogen, second helium, third lithium, beryllium and boron. And you can see the numbers written as superscript and subscript. The number which is written on top is nothing but mass number. So, the first element hydrogen, the number written on top is 1. So, the mass number of this element is 1. Next one, you can see the atomic number. The atomic number of this element which is written below is also 1. So, hydrogen element, the mass number is 1, atomic number is 1. Next element is helium. Helium, the number which is written on top is 4. 4 is nothing but the mass number, and 2 is written below, that is the atomic number. Lithium, mass number is 7 and atomic number is 3. Next, beryllium, mass number is 9 and atomic number is 4. And boron, the mass number is 11 and atomic number is 5. So, with this we know that this also you can find out the elements in the periodic table are arranged according to the increasing order of the atomic number. Now, using this we can calculate number of proton, neutron and electron, and also we can write the electronic configuration of these elements. Now, look at the first element. Mass number is 1, atomic number is 1. So, next column is number of proton. How to find out the number of proton? Number of, that is atomic number is equal to number of protons. So, the number of protons will be equal to 1. Number of neutrons. Number of neutrons means how many? You can subtract the number of, that is number of protons from the mass number. So, 1 minus 1, 0. So, there are no neutrons in the atom of an element of hydrogen. Electron. Electron is nothing but number of proton is equal to number of electron. So, the number of electrons is equal to 1. Now, this there is 1 electron. So, how to write the electronic configuration? So, the first shell, that is around the nucleus, the first shell is K shell. So, 1 electron will be occupying the first shell, 1. Okay, so the hydrogen atom, it will be having the nucleus there will be 1 proton, 0 neutron, and there is 1 orbit, 1 shell, that is K shell, and K shell will be having 1 electron in it. Next one, helium. Helium, the mass number is 4, atomic number is 2. So, how many protons are there? So, number of protons is equal to number of atomic number. So, number of protons will be equal to 2. And then, how many neutrons are there? You subtract the mass number of protons from the mass number. So, 4 minus 2, 2. Neutrons are 2 and electrons and protons will be same. So, number of electrons will be 2. So, here you can see K shell already 1 electron is filled. Now, in the helium has 2 electrons. So, 1 more electron will be occupying the, that is in the K shell. So, 2 electrons will be present in the K shell of an helium atom. So, maximum number of electrons in K shell is 2. So, it is completely filled shell, or it is known as stable electronic configuration. So, this having 2 electrons in the K shell is known as duplet configuration. or it is stable electronic configuration, the outermost orbit is complete. Next come to the element lithium. Lithium has the atomic number 3. So mass number is 7. So number of proton is equal to atomic number. So number of protons will be 3. Then mass number, subtract the mass number and the atomic number or number of protons. So 7 minus 3 will be 4. And number of electrons and protons will be same. So it will be 3. Now look at the electronic configuration. So there are 3 electrons present in an atom of lithium. So out of 3, the first shell is K. So out of 3, 2 electrons will be occupying in the first shell K. So 3 minus 2, how many electrons remaining? 1. So 1 electron will go to the next shell, that is L shell. So the electronic configuration will be 2, 1. Alright, so that is for lithium. So 3 electrons are there. So electrons are distributed in various shells. So out of 3, 2 electrons will be the first shell and then remaining 1 electron will go and occupy in the L shell. Next element is element number 4, that is beryllium. Beryllium mass number is 4 and then atomic number is, mass number is 9, atomic number is 4. So number of protons will be equal to number of atomic number. So number of protons is 4. What is the number of neutrons? 9 minus 4, 5. 5 neutrons are present over here. Number of proton and neutrons, electrons are equal. So number of electrons will be 4. Now we will see how 4 electrons. So electronic configuration will be written only by calculating the number of electrons. Protons and neutrons are present in the nucleus of an atom. So this 4 electrons, how it is occupying? So how many electrons can be accommodated in K shell? 2. So out of 4, 2 electrons will go and occupy in the K shell. 4 minus 2, 2 electrons are remaining. So balance 2 electrons will be occupying in the L shell. So the electronic configuration of beryllium we will write this as 2 and 2, 2, 2. Next, the fifth element in the periodic table is boron. Boron has mass number 11 and atomic number 5. So number of protons will be equal to atomic number, that is equal to 5. And what is the number of neutrons? 11 minus 5, that is 6. So it has 6 neutrons in the atom, in the nucleus of an atom, and then how electrons will be same as number of proton, that will be equal to 5. Now let's see how these 5 electrons will be distributed. So in the first shell out of 5, how many electrons can be occupied? 2. So 2 electrons will occupy in the K shell, first shell around the nucleus, and then 5 minus 2, 3. So 3 electrons will be occupying the next higher energy level, that is L shell. So 3 electrons will be occupying in the L shell. So the electronic configuration of boron will be 2, 3. So this is how one by one the shells are being filled up. So hydrogen is 1, helium has a duplet where the K shell is completely filled, it is known as duplet. Lithium 2, 1, then beryllium electronic configuration is 2, 2, and then boron is 2, 3. So next we will see the remaining 5 elements and then we will study how to draw the atomic orbital diagram of the 10 elements today, and then let's concentrate on that. So the atomic number is 6, the number of proton is 6, number of neutron is 6, so number of electrons is also equal to 6. So in the K shell, out of 6, 2 electrons will be occupying it, and then remaining how many electrons are there? 6 minus 2, 4. So 4 electrons will be occupying in the next shell, that is L shell. So you can see that in the nitrogen atom, the mass number is 14, the atomic number is 7. So the number of protons will be 7, number of neutrons 14 minus 7, it will be 7, and number of electrons is also equal to 7. That is, number of electrons and protons will be same, and number of neutrons you can get by subtracting the number of protons from mass number. Now how to write the distribution? Out of 7 electrons, 2 electrons will be occupying the first shell, K shell. So remaining how many electrons are there? 7 minus 2, 5. So 5 electrons one by one it will be occupying in the next shell, because maximum number of electrons which can be present in the K shell is 2. Next let's see oxygen. Oxygen has a mass number of 16, atomic number is 8. So now how many protons are there? So number of protons will be, that is atomic number is equal to number of protons will be equal to number of electrons, which is 8, and number of neutrons you can get by subtracting number of protons from this mass number, so that is also equal to 8. Now let's see how electrons are distributed in this various shell. So in 8 electron, that is 2 electrons from this will be occupying the first shell, K shell. So that is completely filled. Now remaining 8 minus 2, how many electrons are there? 6. 6 electrons will go and occupy in the L shell. So that is the configuration of oxygen 2, 6. Next atomic number, that is the element is fluorine. Fluorine, the mass number is 19, atomic number is 9. So how you are going to get it? So the number of protons is equal to 9, number of electrons is also equal to 9, which is equal to atomic number. How to calculate number of neutrons? Subtract 19 minus 9, that is 10. So it has 10 neutrons in the nucleus of an atom. Now how to write the electronic configuration? 9 electrons. I told you electronic configuration is how electrons are distributed. We are going to take number of electrons only. So out of 9, 2 electrons will be occupying the K shell. So 9 minus 2, how many electrons are remaining? 7. So that 7 electrons will go and occupy in the N shell. So the electronic configuration of fluorine will be 2, 7. Next, the 10th element is neon. Neon, the mass number is 20 and atomic number is 10. So atomic number is 10 means number of protons will be 10, number of electrons will be 10, which are always equal. And how to calculate number of neutrons? That is mass number minus atomic number or mass number minus protons. So 20 minus 10 is 10. So neon has 10 proton, 10 neutron and 10 electron. Now which number will be taken for distribution? So 10 electrons, how it is distributed in the various energy shell. So the first shell, how many electrons can be occupied? 2. That is the maximum number of electrons in the first shell. So 10 minus 2, how many electrons remaining? 8. So 8 electrons occupy in the next shell L. And I hope you remember the rule, Bohr and Bury. What the rule number 2 says? Rule number 2 says that the maximum number of electrons present in the outermost shell of an electron is 8. So if the next element, sodium, which has a number of electrons 11, so it cannot be 2, 9 because 8 is the outermost shell. So what happens? So this is a completely filled shell. So having 8 electrons in the outermost shell, that is known as octet configuration, or it is known as stable electronic configuration. That means this element is highly stable and it is unreactive. Now let's see the atomic orbital diagram of first 10 elements, how the electrons are distributed and how you can show the electrons in the various shell for the 10 elements. Remaining 10 elements we will be studying in the next class. So children, let's study the atomic orbit structure of first 10 elements and how the electrons, protons and neutrons are represented in the atom of an element by this diagram. So it will be very easy for you to understand how the subatomic particles in the atom of an element it is distributed. Now the first element is hydrogen, having the mass number of 1 and atomic number 1. So when you draw the diagram, atomic structure, in the center it is a nucleus and then it is surrounded by the first shell, that is energy level K shell. So here when you see it, if atomic number is 1, the number of protons in hydrogen atom will be 1. So there is 1 proton in the nucleus, and how to find out the number of neutrons? That is mass number minus atomic number. So 1 minus 1. So in the atom of hydrogen there are no neutrons, number of neutrons is 0. And then electrons. So number of protons is always equal to number of electrons. So it has 1 electron and 1 electron is present in the K shell. This is how you represent. This is an atom of hydrogen. And then how you write the electronic configuration. Electronic configuration can be written by how many electrons are present. It is showing the distribution of electron. So since it has 1 electron and 1 electron is present in the K shell, so electronic configuration of hydrogen will be 1. Next, second element is helium. Helium, the atomic mass number is 4, atomic number is 2. So here number of protons will be equal to the atomic number, that is 2, and number of protons will be equal to number of electrons. So the number of electrons also will be equal to 2. Now how many neutrons are there? Mass number minus atomic number. So number of neutrons will be 4 minus 2, 2. So in the nucleus of helium atom there is 2 proton and 2 neutron. And how many electrons are there in the shell? There are 2 electrons. So 2 electrons, how you can show? Draw one shell, that is a first shell K shell. So there will be 1 electron over here and another electron over here. So 2 electrons are present in the K shell. So that is helium atom. And now how will you write the electronic configuration? Electronic configuration will be written as 2. That means it has 2 electrons and 2 electrons are present in the first shell, that is K shell, and electronic configuration 2. And that means the maximum number of electron in K shell is 2. And that is completely occupied in helium. That means this configuration is known as stable electronic configuration. Because of this helium element, it is inert, unreactive. It will not participate in any chemical reaction. It will not lose electron or gain electron. And this configuration is known as duplet configuration, having 2 electrons in the first shell, K shell, that is known as duplet configuration, which makes it highly stable element. Now, the third element is lithium. Lithium has a mass number 7 and atomic number 3. So here we can calculate, that is atomic number 3 means number of protons is 3, number of electrons is 3. So how many neutrons? Mass number minus atomic number, or mass number minus number of proton. So 7 minus 3 is 4. So it has 4 neutrons. So in the nucleus of lithium, there are 3 proton and 4 neutron. And how many electrons are there? 3 electrons. So out of 3 electrons in the K shell, so how will you write the electronic configuration? K and L. This is a K shell over here, K shell over here. So out of 3, 2 will be occupying in the first shell. 1 electron and 2 electron. Now how many is remaining? 3 minus 2? 1. So 1 electron, you cannot write 3 electron in the K shell because maximum number of electron in K shell is 2. So 2 electrons will be occupied. So next 1 electron will be occupied in the next shell, that is L. So what is the electronic configuration? 2, 1. So 2 plus 1 you will get 3, and that when you write the electronic configuration you can also check it will be equal to its atomic number. Now the third element, the fourth element is nothing but that is beryllium, the atomic number 4. So beryllium mass number is 9 and the atomic number is 4. So mass number 9 means number of protons, that is from the atomic number. Number of protons is equal to 4, which is equal to number of electron, and number of neutrons means 9 minus 4, 5. So in the nucleus of an atom of beryllium, there are 4 protons and there are 5 neutrons. 4 electrons it will be distributed in the shell. So out of that, when you write the configuration K and L, out of 4, 2 will be occupying in the first shell, that is K shell, and 4 minus 2, how many is remaining? 2 electrons. So 2 electrons will be occupying in the, will accommodate in the L shell. So 1 and 2. So the electronic configuration of beryllium will be 2, 2. That is 2, the first one is K shell, and 2 will be in the next shell, that is L shell. Next one is the element known as boron with atomic number 5 and mass number 11. So atomic number 5 means number of proton is 5, number of electron will be same 5, number of neutron, that is 11 minus 5 is equal to 6. So in the nucleus of boron there are 5 proton, there are 6 neutron and 5 electron. How will you write the electronic configuration? Write the shells in this order, K and L. Out of 5, what is the maximum number of electron in the K shell? 2. Right here 2. So 5 minus 2, how many is remaining? 3. So 3 electrons you can accommodate in the L shell. So 1, 2 and 3. So the electronic configuration of boron will be 2, 3. So when you add 2 plus 3 you will get 5. So 5 is atomic number, that is element number 5, that is boron. Next element is carbon with atomic number 6 and mass number 12. So number of proton will be 6, number of electron will be 6, mass means 12, number of neutron, 12 minus 6 will be 6. So in the nucleus of a carbon atom, the atomic number, that is element number 6 is carbon. So it has 6 proton, it has 6 neutron in the nucleus, and then electrons. How to show it? Distribution of electron. So write the K shell, first shell is K. So out of 6, how many electrons can be in the first shell? 2. So show the 2 electrons in the first shell. So 6 minus 2, how many is remaining? 4. So 4 electrons can be accommodated in the next shell. 1, 2, 3 and 4. So the configuration of carbon, that is electronic configuration of carbon will be 2, 4. 2 in the first shell and 4 electrons in the second shell, that is L shell. All of you should label the shell when you are representing it. Next element after carbon is nitrogen. Nitrogen atomic number is 7, mass number is 14. So same way, number of proton is 7, number of electron is 7 and number of neutron, 14 minus 7 is 7. So in the nucleus, proton is 7, neutron is 7, and then number of electrons in the first shell. Write the configuration K and L. First there will be 2 electrons in the K shell, and then right here 2. So 7 minus 2, how many are there? 5. So 5 electrons will then accommodate in the next shell. So 1, 2, 3, 4, 5. So the electronic configuration of nitrogen will be 2, 5. Next element after this is oxygen. Oxygen, here the mass number is 16, the atomic number is 8. So number of protons will be 8, number of electrons also will be 8. Neutron, mass number minus atomic number, or mass number minus number of proton. So 16 minus 8 is equal to 8. So in the nucleus of an oxygen atom, there are 8 proton and 8 neutrons. Now electrons, how you have to show? Electrons occupy the energy levels around the nucleus. So how to write the electronic configuration? Write the shell number K and L. This is the first shell. So out of 8, how many electrons can accommodate in K shell? 2. So write 2 over here, electronic configuration. So 8 minus 2, how many is remaining? 6. So 6 electrons will be occupying in the L shell. So 1, 2, 3, 4, 5 and 6. So the electronic configuration of oxygen is 2, 6. Next element after oxygen is fluorine, F. It is given by the symbol F, capital F. So atomic number is 9, mass number is 19. So number of protons will be 9, number of new electrons is 9, and number of neutrons 19 minus 9, that is equal to 10. So in the nucleus of fluorine atom, there is 9 protons, there are 10 neutrons, and remaining 9 electrons. You have to show it in the energy shell. So write the letter here, K and L shell. So in the first shell out of 9, 2 electrons will be occupying the first shell, that is 2. So 9 minus 2, how many is remaining? 7. So the 7 electrons will be accommodated in the next energy level, that is known as L. So 1, 2, 3, 4, 5, 6 and 7. So 2, 7 is the electronic configuration of fluorine. Next one, neon, that is the 10th element, and in the 10th element, that is neon, Ne, capital N and small e. So atomic number is 10, so number of protons will be 10, number of electrons will be 10, and mass number is 20, so number of neutrons will be 20 minus 10, that is also equal to 10. So this is the nucleus. So in the nucleus, proton is 10, neutron is 10, remaining electron, when you have to show it, write the shell, K shell, out of 10, 2 electrons will be occupying the first shell, that is 2. So next one, 10 minus 2, how many electrons remaining? 8. So 8 electrons will be occupying in the L shell. 1, 2, 3, 4, 5, 6, 7, 8. So the electronic configuration of neon will be 2, 8. Now here what happened? The maximum number of electrons in the L shell is how much? 8. Okay, you have seen by the formula 2n square. So it is 8, and also the outermost orbit, it is complete, it can only accommodate 8 electrons. So this is also known as stable electronic configuration, and neon is an inert gas. It is highly, this one is stable, and then it will not participate in any reaction by losing electron or gaining electron. So it is inert in nature or unreactive. So there are 2 noble gases which we have seen, which belongs to group number 18 in the periodic table. In the extreme right hand side of the periodic table, that is helium with duplet configuration, and neon having 8 electrons in the outermost shell is known as octet configuration. Octet means 8, duplet means 2. So here, so these 2 are said to be the noble gases of stable electronic configuration. So now all of you should draw this neatly in your notebook using a compass, and then represent the proton, neutron and electron neatly, and write the electronic configuration of every element, and also write the mass number and atomic number for each diagram when you are drawing it. Hope you have understood very well. This is very interesting diagram, and in the next class we will study about the another 10 elements, how to write the electronic configuration and draw the atomic structure. Now I want all of you to look into the slides and recall what all we have learnt it and understand the concept very well. So children, let's learn about the distribution of electrons in the orbit, then atomic number, mass number, valency, atomic structure of first 10 elements, that is from the chapter Structure of Atom. So let's recall what we have learned. So what is meant by electronic configuration? The distribution of electrons in the various orbits or shells is known as electronic configuration. What are the rules for distributing electrons in the different energy shells or levels as given by Bohr and Bury? The maximum number of electrons present in a shell is given by the formula 2n square, where n is equal to the number of shell or as counted from the nucleus. Now state the maximum number of electrons in the various shell. The maximum number of electrons in the various shell is, the first shell is K, so it is given by the formula 2n square, so 2 into 1 square, which is equal to 2 into 1, which is the maximum number of electrons in the K shell will be equal to 2. The second orbit or shell is L shell, so the number of electrons will be 2 into 2 square, or it is 2 into 4, which is equal to 8. So maximum number of electrons in L shell can be 8 electrons. Third orbit is M shell, so you can calculate it by 2 into 3 square or 2 into 9, which is equal to 18. So M shell can have maximum of 18 electrons. The fourth orbit or N shell is given by, that is 2 into 4 square or 2 into 16, which is equal to 32 electrons can be accommodated in the fourth shell or N shell. So like that, you can calculate the number of electrons present in various shell by using the formula 2n square. Now, what is the maximum number of electrons that can be accommodated in the outermost orbit? The maximum number of electrons that can be accommodated in the outermost shell is 8. Electrons are not filled in a given shell unless the innermost shells are completely filled. What is meant by atomic number? Atomic number is defined as the number of protons present in the nucleus of the atom. It is denoted by the letter Z. All atoms of an element have the same atomic number, which is represented by the letter Z. Then, what is the relationship between number of protons and number of electrons in an atom? The atom of an element is neutral. The atom of element has the same number of electrons and protons. So, atomic number is a number of protons in the nucleus of an atom. Thus, the atomic number of an element is also equal to number of electrons in the atom of an element. Now, for derivation, this is very important, derivation of number of protons, neutrons and electrons from the atomic number and mass number. Atomic number is equal to number of protons, which is equal to number of electrons. So, atomic number Z is given as number of proton P, which is equal to number of electrons. Mass number represented by the letter A can be given as number of protons plus number of neutrons. So, mass number A is equal to P plus N. Number of neutrons, if you want to calculate it, you can just subtract the number of protons from mass number, you will get the number of neutrons. So, number of neutrons is equal to A minus P. Number of neutrons can also be calculated by this method, because number of protons is equal to atomic number. So, number of neutrons is equal to mass number minus atomic number. You will get the number of neutrons. So, N is equal to A minus Z. What is meant by mass number of an atom? The mass number of an atom is the total number of protons and neutrons in an atom, in the nucleus of an atom, which is collectively called nucleus. It is denoted by the letter A. Mass number is equal to number of protons plus number of neutrons. So, it is given as A, which is equal to N plus P. N is neutron and P is proton. Write the notation for the atom of an element. So, atom of an element is given by this symbol. So, X, suppose it's an element, hydrogen, helium or nitrogen and carbon. And this letter A represents the mass number, and which is a superscript, and subscript Z is the atomic number. So, this is how the atom of an element is notated. Now, you have to calculate the mass number and atomic number of two elements X and Y, which is given that element X as number of protons in element X is 6, neutrons is 6, element Y the number of protons is 7 and number of neutrons is 7. So, how to calculate the mass number? So, what is the mass number and atomic number? So, mass number of X, this element, is equal to number of proton plus number of neutron, that is 6 plus 6 is equal to 12. And what is the atomic number? Atomic number is equal to number of protons. So, the atomic number of element X is 6. What is the mass number of Y? Y will be number of proton plus number of neutrons. So, mass number of Y is 14 and atomic number of Y, which is equal to number of proton, which is equal to 7. So, in a shell, when you draw the atom of an element, so the last shell of an atom is called the valence shell. What is the last but one shell? Second last shell called? The last but one shell in an atom is called penultimate shell. What is meant by valency of an element? The combining capacity of an element is known as its valency. What are valence electrons? The number of electrons present in the outermost shell or valence shell of an atom are known as valence electrons. Now, this is the explanation which I had given to you. So, please see it. So, these are the, you have to write down the electronic distribution of in the first 10 elements. So, the first 10 elements in the periodic table are hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So, the first element is hydrogen. The symbol is given as H, capital H. atomic number is 1. So the electrons, the one electron will be filled in the first shell, that is K, and maximum number of electrons in K shell is 2, maximum number of electrons in the second shell is 8, given by the formula 2n square. So hydrogen 1 electron is there, so 1 electron will be occupying in the first shell. Helium, atomic number 2, so the 2 means number of electrons is 2, so K shell, the 2 electrons will be occupied, and this K shell will be completely filled. So having 2 electrons in the K shell is also known as duplet or stable electronic configuration. Lithium is the third element with atomic number 3, that means number of electrons are also 3. So out of 3, 2 electrons will be occupying in the first shell, K shell, and 3 minus 2, 1. 1 electron will it will be occupied in the next energy level, that is L shell. Beryllium with atomic number 4, or number of electrons are also 4. So out of 4, 2 electrons will be occupying in the first shell, and remaining 2 electrons will go and it will occupy the next shell. It will be filled in the next L shell. Boron is a fifth element with 5 atomic number of 5 electrons. So out of 5, 2 electrons will be only occupied in the K shell because 2 is the maximum number of electrons. 5 minus 2, remaining 3 electrons will be occupied, jump into the next energy level. Atomic number 6, that is carbon. Carbon, the first 2 electrons will be completely occupying the K shell. 6 minus 2, remaining 4 electrons will be occupying in the L shell, accommodated in the L shell. Nitrogen is the element with the atomic number 7. So out of 7, 2 electrons will be occupying in the first shell, K, and then 7 minus 2, 5. 5 electrons will be accommodated in the next shell, that is L shell. Oxygen with atomic number 8. 8 means it has 8 electrons and 8 protons. So out of 8, 2 electrons will be accommodated in the K shell, and remaining 8 minus 2, 6. 6 electrons will be accommodated in the L shell. Fluorine. Fluorine with atomic number 9. So here what happened? The first 2 electrons will be occupying in the will be accommodated in the K shell. 9 minus 2, 7. 7 electrons will be accommodated in the next shell. The 10th element is neon with 10 atomic number 10 and number of electrons is 10. So out of 10, 2 electrons will be accommodated in the first shell. Remaining 10 minus 2, 8 electrons will be accommodated in the last shell. So that means by the time we reach neon, our L shell is completely filled because it is having maximum number of electrons in L shell can be only 8. So having 8 electrons in the outermost shell is also known as octet. Octet means 8 electrons. So L shell is completely filled, so it is stable electronic configuration, and this is a noble gas. Because of this, noble gases are inert and unreactive. Next, as I showed you the diagram, all of you must draw this diagram neatly. This is the atomic structure of a first element, hydrogen. This is the nucleus. It has 1 proton and 0 neutron and 1 electron. So 1 electron will be occupying in the one shell. It has one shell, that is K. So 1 electron will be present in the K shell. This is the atom of helium. So helium has 2 proton, 2 neutron and 2 electron. So the 2 electrons will be completely occupying in the K shell. So helium, the electronic configuration is 2, which is given inside the bracket. Now third element is lithium, 2 plus 1, 3, atomic number 3. So lithium, this is a nucleus. So here protons and neutrons are present. This is known as a nucleons here, protons and neutron. And then the 3 electrons, out of 3, 2 electrons will be occupying in the L shell, and the next 1 electron will be accommodated in the L shell. This is K shell, L shell. Beryllium with atomic number 4. So out of 4, 2 electrons in the K shell, and then remaining 2 electrons in the L shell. And this is the center of the atom, that is the nucleus, where the protons and neutrons are present. Next element is atomic number 5, boron. So 5 is the atomic number. So out of 5, 2 electrons will be accommodated in the K shell. Remaining 3 electrons, 1, 2 and 3 will be accommodated in the L shell. Next element is carbon with atomic number 6. So out of 6, 2 electrons in the K shell. All of you should label the K shell and L shell. And then remaining 6 minus 2, 4. 4 electrons will be accommodated in the L shell like this. Nitrogen with atomic number 7. So out of 7, 2 electrons will be accommodated in the K shell, 1 and 2. And remaining, that is 5 electrons, 1, 2, 3, 4, 5 will be accommodated in the L shell. So these are all known as electronic configuration, which is given in the bracket. Very, very important. And next element with atomic number 8 is oxygen. This is a nucleus where protons and neutrons are present. 8 proton, 8 neutrons, and the 8 electrons are found in the various shell. So out of 8, 2 electrons will be accommodated in the K shell, and remaining 6, 1, 2, 3, 4, 5, 6 will be accommodated in the L shell. Fluorine with atomic number 9. This is the nucleus where the protons and neutrons are present, and the 9 electrons are accommodated in 2 shell. First shell is K, L. K shell will have 2 electrons. Remaining 7 will be accommodated in the L. 1, 2, 3, 4, 5, 6 and 7. Next, the atomic number 10, neon. So neon, the number of electrons is 10, number of protons is 10, and number of neutrons is also 10. So protons and neutrons are found in the nucleus, remaining the electron. So out of 10 electron, 2 will be occupying in the K shell, completely filled. After that is getting filled, the remaining 10 minus 2, 8. 8 electrons will be getting filled in the L shell. So 1, 2, 4, 5, 6, 7, 8. So this is how you have to draw the atomic orbital structure of first 10 elements, and what is given in the bracket is known as electronic configuration. All of you should write it neatly and label the K shell and L shell for each diagram. Next, this is the another example of how you can find out the number of neutron, proton and electron in an atom. So atomic number 3, a one element with atomic number 3, 8, 4, 6, 9, 10, 5, 7. These are the elements where the atomic number is given. In this column, you have the mass number of the atom. So calculating this, you can, looking at this mass number and atomic number, you can calculate number of neutron, proton and electron. So here the first and second I'll explain to you, remaining you can do it. So here the atomic number is 3, mass number is 7. So how will you calculate number of neutron? Mass number minus atomic number. 7 minus 3 is 4. So that's how you'll get the number of neutron, that is A minus Z. How can you calculate the number of proton? Number of proton is equal to atomic number, which is equal to 3. Number of electrons is also equal to atomic number, which is also equal to 3. So which is the element having the atomic number 3? That is lithium. Now look at the second example. Atomic number is 8, mass number is 16. So how will you calculate the neutrons? 16 minus 8. So number of neutron is 8. And number of proton is 8, which is equal to atomic number. Number of electron is 8, same as atomic number. And the element with atomic number 8 is oxygen. Similarly, you can calculate all this and then you can write down. So you can see the atomic number and number of proton and number of electron will be same. Only the neutron you can get it by subtracting mass number, that is atomic number, from the mass number. You can get the answer in this column. You can calculate the number of neutrons and learn all the elements according to the atomic number, that is first 10 elements properly, and find out the names of that. Okay. Now you have to do this worksheet in your column. After learning everything, please find out, write this in your notebook, make a tabular column and find out number of proton, neutron, electrons and electronic configuration of the following elements: helium, carbon, nitrogen, oxygen and fluorine. This is given to you. After learning it, you must write down without looking into the textbook or notebook. Next, you have to write the notes neatly in your notebook, send it for correction, take the picture and send it to me. Then read the chapter 4, page number 49 to 52 in your science textbook. Learn all the definitions and questions well. Draw the atomic structure of first 10 elements and represent the electronic configuration, number of proton, neutron and electrons, and you can show that in your activity book. Okay, or you can take an A4 size paper, you can draw that. Draw the diagram neatly using a compass. Okay, don't draw the freehand drawing, and very neatly you must show the number of electrons, how it is distributed, and when you're drawing it, the size of the nucleus should be small. And then draw it and send the notes to me. Hope all of you have understood it well. Thank you, children.